Hello again, welcome back to RP-0 America. So we're still in the territory between North America and Africa. In my last video I placed the Mercury capsule with no crew currently in orbit using actually a KOS script of my own and an Atlas launch vehicle, Atlas D. And so just going to do a couple orbits of the Earth and then we're going to bring it back down. Yes, we'll have to capture some science so it doesn't stop jumping us out of time warp. Hopefully it won't do that each time we pass over a new biome, but who knows. So that was part of Africa, and we're going to pass over another part right now. And let me just check what's the brightness settings. There we go. So this is, again, the random light coming from no real source there, lighting the back of it, of the capsule. But when I turn that off, there we go. See, it's kind of, I prefer the darkness and the contrast of the capsule like that, but I understand for videos it's probably better to have it lit a little bit more like that. But tell me what you think. So we're just going to complete a couple of orbits. Watch a couple sunsets and sunrises. So let's see the capsule as dark and wait for the next sunrise. I think there should be a reasonable speed. I'll just make sure it gets at least one orbit around. And because I'm using the FASA recreation, I really feel no need to do a test like this. I'm just doing it kind of as an interim video while I develop my, whoa. I think you could see Florida very briefly as I flew over it again there. While I work on a lunar lander, this will give me a chance to do that. Give me a couple videos. I think once I develop a really small, soft lunar lander craft, that'll probably be my last video in 1.0.5. Alright, so let us wait for the sun to come around again, give us another sunrise. So once we've done a couple of orbits, there we go. So now we're out into the daylight again. So even with the relatively low frame rate, whatever this ends up being, I still find it looks really good. Alright, so we're going to come back over. So see, we're going to pass, every time we come around, 90 minutes have passed, and so the Earth has rotated on a little bit more and a little bit more. So Florida's moved out of the way, so there you can see California, or well, at least that's California, and this is the Baja Peninsula, I believe. Passing over Texas or other states, and then we get the Gulf of Mexico here. And you can see Florida north of us, and the Isle of Hispaniola, and Cuba, and all kinds of things down here that we'll be able to see, and a little bit of South America, I think, is at the periphery there. So I think that's a sufficient number of orbits. We've gone around a few times. We still have about a day worth of battery. Like if you design I like to use these FASA craft myself, but if you design something yourself, I definitely encourage you to do a non-crewed test flight before you send up any crew, because all kinds of things can fail. Okay, so if I imagine the Earth has rotated just a little bit more, I think that's a good landing site, just somewhere in the Pacific, maybe a little closer in there, because Hawaii is somewhere in this giant ocean here, so I think that'll be good. So I'll just warp to that. 55 minutes from now, another, most of an orbit. Yeah, I've sent up a lot of crewed capsules in the last couple of days as I've been kind of working on realism overhaul for 1.1, and thermal parameters need changing basically to make sure that the heat shields still last, because every time there's big changes in KSP, that'll kind of work its way up and cause various interesting issues and requirements for change in RSS, thermal numbers, and realism overhaul as well. So I have brought this capsule down many, many times in the last few days in 1.1. So this won't be using the numbers I just set up myself. But yeah, I determined those what values the heat shield has to have, because the heat shields, Nathan Kell added a number of interesting features for the heat shields in 1.1. So rather than just this ablator material disappearing and your capsule getting lighter, instead ablator is going to convert over to charred ablator, so the mass of your capsule will stay similar and only lose a few kilograms, like would be realistic. Okay, so we're coming around the node here, so let's just lock our, well, we can't lock our position. Okay, let us tell it to Let's use Smart ASS and turn the lights back on. Sorry. All right. So they wouldn't, when they did this, I believe they didn't actually point directly that way. I think they would point down about 30 degrees, something like that, to give the craft a bit of a downward velocity as well. And that should be good. And also kind of balancing how quickly the ablator goes away and what the peak temperature that the capsule hits. So to make it such that if you perform reasonable kind of matching, near reasonable and historic capsule reentries with the FASA capsules, you will survive. And if you try to send the Mercury capsule to the moon, you will not survive coming back at that velocity. So thankfully that was able to pop off for us. There's a chance that could fail. Like for the Vostok, the Soviet craft, they tried to drop that pack and it failed. During my previous test, I actually just left it on to see what would happen, because during the Mercury-Atlas 6 flight, the first American in orbit, John Glenn, I believe after they fired the retro pack, like I just did, and it's when they still had it on, they were getting confusing signals that were telling them that actually the heat shield airbag, so this heat shield in reality was a bit separate from the capsule, and before they hit the water, the goal was to I can't lock the SAS. Once they'd slow down and before they hit the water, they would drop the heat shield. It would pop and there'd be an airbag between the capsule and the heat shield, and that would kind of make it a bit easier to land on the in the water. And they were afraid that had some signal system had told them that had already deployed, which was terrifying, because if you want your heat shield to be firmly and certainly applied to your capsule when you hit the atmosphere. And so to make sure they retain that, because they had the straps to hold the retro pack onto the capsule, they left that retro pack empty of solid fuels on, which itself was kind of risky and dangerous. It was a difficult decision for them to make. Sorry, it just keeps rotating around as I time warp. Soon we'll be bumping the atmosphere. Because the retro pack, they'd never really simulated, they'd never done that in any tests. For all they knew, the retro pack had the potential to damage the heat shield more than anything else it could. And so retaining it, John Glenn's, as they hit the atmosphere, he could see parts of the retro pack being burned off and blown off during reentry, and he wasn't certain from the inside of the capsule. And at that point in reentry, the heat of the plasma, the air in front of the capsule is so intense that it sends the hotter something is, the higher frequency signals it creates. It generates light, just like if you turn on an element on a stove and you get infrared, you can feel as heat, and then red. So the hotter it glows, the higher the frequency is. And it was sending out interference that meant they couldn't communicate by radio. So like in Apollo 13, when they talk about the blackout period, he couldn't communicate with the ground and they couldn't communicate with him, and he didn't know whether he was seeing bits of his heat shield fly past or bits of the retro pack. So very terrifying situation. But thankfully it worked. It succeeded, and if I recall correctly, but I may not, certainly worth looking up the history for yourself, it was just a faulty sensor that had told them that. And in practice, the heat shield and airbag were just fine. The airbag had not actually deployed in space. The airbag currently isn't something modeled on the FASA craft, but in theory somebody could remodel it so that that's possible. Just like at some point in the past there was a plug-in for the Soyuz craft, because right before it impacts on the ground, it has these little, it's still to this day, if you watch aerial footage of a Soyuz capsule coming down, you can see this big poof of dust and everything from the ground that comes up right before it hits the ground, and that's because it detects, we're right above the ground. It fires these solids to slow it down, slow the capsule down even further than the parachute does, right before it hits the ground. And there used to be a mod that did that, but I believe that it just kind of fell out of support. You know, whoever created it originally just created it and didn't continue to develop it as KSP, continued to keep changing underneath them, and so that mod just doesn't work anymore, which is a shame, but understandable. You know, it's modding and developing things for KSP it's unpaid work. So at some point somebody might come around and, you know, remodel the Mercury so it has the separable heat shield, or, you know, recreate that the ability for those Soyuz solid engines to run again, which would be neat. All right, it looks like we're successfully coming down in the ocean. You can see the clouds that we are well above. I look forward to using the highest quality Linux clouds. I'm not sure what the texture quality is, if they're 4K or 8K, that can be used in 1.1. But I look forward to using those pretty soon. Yeah, I think this will be my last kind of return of a capsule in 1.0.5, or at least in my RP-0 career. It's very wobbly. I think, is it this mod or no? I think there's another mod. So I think this mod lets you kind of look up science equipment that you have. But there's another one like Crew Manifest or something that isn't Crew Manifest that would let me dump the HDP, the high test peroxide, which was dumped before the Mercury capsule was recovered. So let's pop that off, and I've set it up so that just staging the parachute just arms it, and it looks like we were down at a low enough altitude, which was good. Low enough altitude that the drogue chute popped out. I don't know parachutes all that well, but the way I think it works, that it usually works, what I usually see in video or pictures, is that a drogue chute is like a little chute, or maybe there's a drogue chute for the drogue chute, who knows. It's just a little chute that it's like very basic, very guaranteed to deploy, and it just provides enough additional energy to pull out the heavier shield, or the heavier parachute. But I don't know. I could be wrong in the naming of that, but that's definitely not modeled in any of the chutes mods I've seen, where just a little chute is used to pull out the real chutes. Because they come out, take a few seconds to deploy, and once they're catching air, they have enough oomph to pull out the big chutes. And I need to make sure that I'm looking from a high enough angle that I don't impact, the camera doesn't impact on the water, because for some reason that freezes for me. Might just be because I'm so high, so close to the memory limit. And there's that 1.0.5 crazy like shadow on the parachute wires that always occurs. I believe that's no longer occurs in 1.1, which I look forward to not seeing anymore. And sploosh, we should hit the water, and there we go. We successfully placed a capsule in orbit and brought it back down. And then, you know, the Navy recovery team would pick it back up, and that would be that. So that's what we've done. We've placed the Mercury capsule into orbit and brought it back with no crew as a good test. And I will now continue developing a lander in order to kind of show like the lowest tech soft landing on the moon that I can personally perform fairly easily. I've tried kind of doing crazy things before that, like say use a custom solid to slow you down when you're in the vicinity of the moon. But really, like I noted down some numbers, and you need about 3.1 kilometers per second of TLI, which something like the Agena can deliver, and then you need about 1 kilometer per second to slow you down into a lower lunar orbit, and then another 1.7 kilometers per second to get to the ground. So from low Earth orbit, you need like almost 6 kilometers per second of delta V, and you need avionics at every step to be able to control it. So placing that with an Atlas Agena, I just didn't find it feasible at this point, because say I need to fire the Agena once to get into orbit, and then I need to fire it one more time to send it towards the moon, and even if it had delta V remaining, I don't have ignitions remaining. So I'll do some fiddling. It becomes a bit tricky to recover the capsule, so I'll just do it from the Space Center if it will let me leave. I need to wait for that orange to become. Oh, I missed it. I missed it twice. Come on, stop dancing around. Anyway, I can recover that on. Oh, there we go. Recover that on my own time. Yeah, that's what I'm going to design. I've got a bit of a draft design. I'm not sure whether I'll use a solid to slow me down. to deliver some of that delta V to slow me down near the lunar surface. I do know that my basic probe that I've designed, Excel, let's see, just pull up my little spreadsheet, because I use RCS for the final stage, and it delivers 1200 delta V, which isn't bad, but it's not even enough to go from low lunar orbit to the surface. So I definitely have a lot of design work ahead of me to be able to do a soft landing on the moon. But I want to show that off because it's one of the more difficult things I find to do early in a career. Like once you have a Centaur, say, and you can throw lots of mass at the moon, sure, right? You can land a pretty beefy lander on the moon. But before that, it's quite tricky. So I'll see, one of the methods that I can figure to do it. So thanks for watching. This has been RP-0 America. Goodbye.